Hello, geometry folks. We just learned about translations in class, and our new transformation is going to be reflections. So I'm sure you can about imagine how this is going to work. Reflections across x-axis, y-axis, maybe a line. Anyway, what we're going to need today is the notes that I gave you in class and a pen or a pencil. So our next type of transformation is a reflection, and the definition of a reflection is a type of transformation where a figure is flipped over a line. So you'll see what I mean when we look at this example. So we have the image PQRS, and I don't know why this shape wasn't filled in, but let's connect P and S, those points, and make this an actual shape. So in the top box here, we're going to reflect first over the x-axis. So reflection and x-axis, and I would write that down if I were you. So before we actually do the reflection, we should write down the ordered pairs or the coordinates of our pre-image points. So point P is -2, up 1, 2, 3. Point Q is -2, 1. R is -3, 1. And S is -3, 5. Those are just the ordered pairs or the coordinates of our 4 pre-image points. So now we're actually going to reflect over the x-axis. And remember, the x-axis is the horizontal line. So let's just pick a point. I'm going to start with Q, and we notice that Q is 1 unit away from the x-axis. At the x value, x is -2. So at that same value, I'm just going to move down 1 point in the opposite direction. What we're trying to do, and I'm going to label that point Q prime, what we're trying to do with reflection is use that line as a mirror to create a mirror image. So we're not sliding the image down, we're trying to reflect it over the line x-axis. So this is my first point. Now we'll do point R. R is at the x value, -3. So at that same value, it's 1 distance away and it's up. So now I'm going in the opposite direction, down 1 unit. So that would be R prime. Now let's do the last 2 points, S and P. P is 1, 2, 3, 3 units away from the x-axis. So I'm going to go 3 units down from the x-axis. So 1, 2, 3. And it's at that same x value. We don't go left or right anywhere. We just go up and down in this case. And then, so let's label that P prime. And finally, our point S is 5 units away from the x-axis. So I'm going to go down 5. 1, 2, 3, 4, 5. So that is S prime. So let's connect our image or our new image, our shape of the quadrilateral. So let's shade that all in. And then we're going to write the ordered pairs or the coordinates of those 4 new points, P prime, Q prime, R prime, and S prime. P prime is -2, -3. Q prime is -2, -1. R prime is -3, -1. And S prime is -3, -5. If we look now at our pre-image points and our image points, or our coordinates of both, what do we notice as a pattern? Well, our x values actually didn't change at all, did they? This is -2, this is -2, and -3, -3 stayed for points P, Q, R, and S. What changed is the sign for the y value. So down here in our right-hand corner, this box will give us a shortcut. We said from the original shape PQRS, our XY value changed from XY to X negative Y. Our Y signs changed from the pre-image point to the image point. So this is just a shortcut. Rather than counting it out like I did and trying the 2 different columns of the ordered pairs, this can just be a shortcut for you so you know exactly where to plot the points. So let's try a reflection in the y-axis. Reflection, and this will be your second box in y-axis. And remember, the y-axis is the vertical line. That's our y-axis. So now we're just doing the exact same thing, except we're flipping it over the vertical line, x equals 0, which is our y-axis. So now we're looking at the point and its distance away from the y-axis. So at y is equal to 3, p is 2 units to the left. So now I move it 2 units to the right, and I'm going to call this p double prime. We've already labeled a shape with prime, so now we're going to use double prime, just so that we can distinguish it between the 2 points. So that's P double prime. Now let's try Q double prime. Q is 2 units away from the y-axis at y is equal to 1. So at that same y value, I'm moving to the right 2 units rather than to the left. So that's Q double prime. And then S would be up here. We moved 3 units to the right rather than to the left of the y-axis. And then R would be down here. So let's connect those points, shade our shape. If you wish to use a straight edge, go for it. That's fine by me. I just don't have one. So this is our new shape, or our new image, I should say. The shape stayed the same. It's still quadrilateral, but we just reflected it over the y-axis. So do you see how these 2 images are mirrors of each other? Well, we should be able to notice that. So let's go back down to our bottom box here, in our blue box, the reflection in the y-axis. And we're going to just label our points just like we did for the top. And our original pre-image points shouldn't have changed. So we can copy those from the box above us. So that's -2, 3, -2, 1, -3, 1, -3, 5. Those are the same ordered pairs or coordinate points as our pre-image in the first example because the pre-image was the same. So now let's look at what the ordered pairs or coordinates are for our P double prime, Q double prime, R double prime, S double prime. P double prime is +2, +3. Q double prime is +2, +1. R double prime is +3, +1. And then S double prime is +3, +5. So if we compare again our columns, our left column of our pre-image coordinates and our right column of our image coordinates, what changed? Only the sign of the x values changed. So down in our shortcut box, it's going to be -xy this time because our y values didn't change. So y is still y, but the x value sign changed. So we label that as a -xy. What if we were to do both at once? If we were to reflect over the y-axis and the x-axis, or the x-axis and then the y-axis? Well, by looking at our shortcuts and by the patterns that we've seen, both signs would change. So instead of xy for our pre-image, it would go to -x, -y. So now let's take a look at some examples. So for this first example, it's telling me to reflect the triangle JKL over the x-axis. And if you remember from our cheat sheet box, our x, y coordinates change to +x, -y. Remember, our y values are going to change. So you could do what we did on the last slide and plot all the points and then figure out what the new coordinate pairs are for those 3 points. But I'm just going to use the shortcut. So that's up to you what you want to do. It's not wrong to do it the way we did it on the last slide. It just takes some time. So if you wish to use the shortcut, that's how I'm going to do it too. So first, let's label our points J, K, and L. So J is the coordinate 1 up 1, 2, 3. So our coordinate for J is 1, 3. And our coordinate for K then is 3, -2. And our coordinate for L is 1, -2. So for our new points, J prime, K prime, and L prime, we just need to negate the y value. So the x's will stay the same. So for j to j prime, 1 will be the same. And instead of 3 for our y value, it's going to be -3. For k prime then, our x value, excuse me, is going to stay the same. So 3 will be 3. And -2 will be a +2 because we're changing the sign on our y value. And last, for L to L prime, 1 will be the same. Our x value doesn't change. And our y value changes, so it goes from -2 to +2. So let's plot these points. J is a +1, -3, so to the right 1, down 3. K prime is over 3, up 2. And L prime is to the right 1, up 2. So if we connect these points, I should label my points. This was J prime, this was K prime, and this was L prime. This is our image now from our pre-image. This example is really tricky because the pre-image landed on the axis that we were reflecting over. So all we did was flip it, and it kind of seems a little weird compared to our last example because it lied on the x-axis, but trust me, it would be the same. So that's our reflection of our new triangle. Let's look at an example where we flip the triangle over the y-axis or reflect triangle ABC over the y-axis. So remember, my y-axis is this vertical line, and if we want to use the shortcut, which is what I'm going to do, what changes? Which value? Our x value changes. So it goes from xy points to negative xy points. So let's first write our points of our pre-image triangle or our original triangle ABC. Point A is the coordinate 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, 5, 6, negative 6. And then point B then would be at the ordered pair negative 3, negative 2, and point C is at negative 1, negative 6. So from these points, I'm just going to change the sign of the x value because that's what my shortcut rule says to do. So our new point for, oh, actually I should say A prime, B prime, and C prime. So starting with A, from point A to A prime, all that changes is my x value. So rather than negative 5, negative 6, it's going to be 5, negative 6. That's my new point. And then my B point to my B prime would be 3, negative 2. And then C would be 1, negative 6. So let's plot those points. So A prime is at 5, 1, 2, 3, 4, 5, plus negative 6, 1, 2, 3, 4, 5, 6. So that would be A prime. Let's reflect B then. That ordered pair is 3, negative 2. So this is where B prime would lie. And then C prime is 1, negative 6. So this is where C prime would lie. So then we connect our points and shade our triangle that way. Again, if you wish to use a straight edge of some kind, you can. So if we look at our pre-image and our image, I did the exact same as if you were to plot the points. C is one distance away at the value negative 6 on the left, and so I would move it to the right 1 here. B was 1, 2, 3 distance or units away from a y-axis, and so I went 3 units away in the opposite direction. A was 5 units away on the left side, so then I moved 5 units to the right. So if you want, you can just plot the points as we did on the first slide, but we see now that it's the exact same, whether we use the shortcut or plot them like we did on the first one.
Okay, this next question is asking us to describe the reflection that happened from triangle RSQ to triangle R prime S prime Q prime. So if you had to draw, or if you had to write it in words, what happened, how do you think this was reflected? So some things you may write down is, do you think it was only reflected once? Do you think it was reflected multiple times? If you think it was reflected multiple times, like which way did you think it was reflected first and which way did you think it was reflected next? So why don't you guys try this one on your own, and when we come back to class, we'll share out our answers on what happened, or what you think happened, that is. Okay, so this question is asking us to reflect the triangle over the line y is equal to x, which is not an axis. It's not a y-axis or an x-axis. When lines are written, they typically can be remembered as y is equal to mx plus b. Remember this slope-intercept form from Algebra 1 where m is our slope and b is our intercept? So in this equation, we technically have y is equal to 1x plus 0. It's just not written that way where my y-intercept is 0 and my slope is 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. and so on and so forth. So if we connect those dots, it's this line that we want to reflect over. So when we're reflecting over a diagonal line like this, the little shortcuts kind of get thrown out the window, and it just comes down to counting, okay? So I'm going to do the reflection in a different color. So if we want to map C to C prime, we have to count how many distances away it is from this red line or my reflection line. So if it's a diagonal distance of 1, that means that C prime has to be over here. And so if we count B, we're going 1, 2, 3 diagonal boxes away. So we have to count in the opposite direction away from this line to get B prime. So 1, 2, 3. So that would be B prime. And now let's count A. So 1, 2, 3 and a half-ish. So if we go a half, and then we go 1, 2, 3. A prime should be right about here. So that's how we reflect when we don't have shortcuts. So if we have a line that's not an axis or not both axes, it's just going to have to be defaulted to counting. And I know it's a little rough counting, but it's diagonally counting for that example. Okay, we're going to try another line that's not an axis, except this time it's going to be a vertical line at x is equal to -2. So at x is equal to -2, so -1, -2. So at this vertical line, if you don't remember why x is equal to -2 is a vertical line, I want you to star this part in your notes, and then you can ask me when we come to class next time, okay? So because this is not an axis, this x is equal to -2, then I want you to count the distances like we did on the last example. So let's count how many boxes this is from A, or A is from the reflection line, and then we're going to have to count that many in the opposite direction. So A is 1, 2, 3, 4, 5, 6, 7 boxes away. So let's count 7 in the other direction. 1, 2, 3, 4, 5, 6, 7. So that's where A prime is for our image. And now let's count C. 1, 2, 3, 4. So count 4 in the opposite direction. 1, 2, 3, 4. There's C prime, and let's count B. 1, 2, 3, 4, 5, 6, 7, 8. Count 8 in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8. Here is B prime. So connect those 3 dots to get your triangle and shade in for your image. And that is our last question for today. So I want to thank everybody for taking such good notes. Remember, always, if you have any questions that may have come up while you've been watching this video, star those portions in your notes or asterisk them or highlight them or something, so that when you come back to class, you can ask me clarifying questions. Okay, other than that, have a great night.